So I got good news and bad news. The good news is there are no more transformations to look at. We've done them all, right? Our translations, our reflections, our stretches and shrinks. The bad news is we got one more family, our circle family. But you should be somewhat familiar with this with geometry. So let's just go back and look at our unit circle first of all. So it's a circle with a center 0, 0 and a radius of 1. And I got this drawn right over here. And with that radius, I can actually write the equation for the circle just by using that radius of 1. So what we need to use is the distance formula. And if you remember the distance formula, the distance equals the square root of x2 minus x1 squared plus x2, y2, my fault. The distance of the x's and the distance of the y's squared, just like that. Okay, it's kind of based off our right triangle. Remember our Pythagorean theorem like that. That's where that comes from. Well, let's plug in our information. We know the distance is 1, so d equals 1. And then the square root of, well, x minus 0 and y minus 0 for our different things. So if I take x minus 0, that's just x. And if I take y minus 0, that's just x. So I'd get 1 equals the square root of x squared plus y squared. All right, that looks nice. Well, let's kind of work with this a little bit. How do I get rid of the square root? Well, to get rid of a square root, we square. That's the inverse. And if I do anything to one side, I do it to the other. So 1 squared is 1. I square that, I get x squared plus y squared. And that's it. That's my equation of a circle. And that's only when the circle has a center of 0, 0. Okay, and if we want to shift the circle, if we want to have a different center, that's where you probably had in geometry. This should look familiar. You had like x minus h squared plus y minus k squared, and that equaled 1. Well, remember that's our shift in the horizontal direction, and that's our shift in the vertical direction. Right? And so that's what we're actually learning this chapter. So that's kind of nice. So that should be familiar from last year, hopefully. And then let's just talk here. Is this a function? Well, if I do the vertical line test, I crossed it twice. So it is not a function. And what's the domain and range? Ooh, that's kind of tricky. So the domain of this guy would be, well, use your radius. So this point is, looks like -1, 0. This point is 0, 1. This point is 1, 0. And then we got 0, -1. So it looks like our domain are x's. So that would be from -1 to 1. So from -1 to 1. And we include the -1 and 1, so I got the less than or equal to's. Same thing with a range. It should be the exact same thing for our unit circle, just like that. There we go. So it doesn't go on forever in either direction because it's a circle. How do we graph it on a calculator? Just think. Calculators only graph functions. And this is not a function. So how am I going to graph this? Well, we need to get y by itself, right? Because the only way you can graph on a calculator is if we have y equals something, right? Because this is like y1, y2, so on and so forth. So let's work with that. Well, let's get our y squared by itself first. So let's subtract the x squared to the other side. And I got y squared equals 1 minus x squared. All right, very nice. And to solve for the y, I need to square root because that's the inverse of squaring. And whatever I do to one side, I do to the other. So y would equal, well, be careful. Remember, whenever you square root on both sides of an equation like that, it's always plus or minus the square root of 1 minus x squared. So there we go. I could plug that in to my calculator, and it should graph me a circle. Let's give it a shot. So I'm going to have to do two separate ones here. I got to go this and then minus. So I'm going to go square roots of 1 minus x squared. Good. And then I'm going to do negative the square root of 1 minus x squared. Let's go ahead and graph. Ew, that doesn't look very good. Maybe I might want to go with zoom standard to take a look. So I can go -10 to 10 in my x and y axis. And there it is. Whoa, that doesn't look like a very nice circle, does it? Well, why? Because this is from -10 to 10 and -10 to 10. Well, is your screen on a calculator a perfect square? It is not a square. It's a rectangle. So I need to shift my window so it looks like a square. Well, what do you think we should choose out of our zooms, you think? What about zoom square? Ooh, crazy. So this will give your window a square look to it. So if I go zoom square, there's my circle. And I might want to zoom in on it. So if I go to my window, in order to zoom in on it, I have to keep the same ratio of numbers of my x's and y's. So since I have about negative 15.16, I'm going to write that. So my x's, I got negative 15.16 to 15.16, and my y's were 10, I believe, negative 10 to 10. So if I want to keep the same ratio, I just have to divide them all by the same number. So maybe I might want to divide these all by 2. So let's go ahead and do that. If I divide them all by 2, I would end up with negative 7.58 and 7.58. And I can keep counting by ones, that's fine. If I divide these by 2, I'd be at negative 5 and 5. So there we go. Let's go graph that now. Yeah, now that looks like a circle. See, perfect. There we go. Okay, so at least we know how to graph this on a calculator now. So here's our parent graph for the top half of a circle, right? It's basically the square root of 1 minus x squared, so we're not including the negative because that would do the bottom part of it. So those are our key points. Here's our key points, right? 0, 1, 1, 0, negative 1, 0. Those are key points on our parent graph of our circle, especially the top half here. So knowing that, we should understand if we would stretch our circle horizontally and or vertically, we would get what we call an ellipse. Okay, it's an oval, but in math we call it an ellipse. So for example here, if I take a look at this first guy, this looks like it's going to stretch by a scale of 5, stretch vertically, right? And here we got a horizontal stretch by a scale of 2. Okay, and is it shift left or right? No, there's no pluses or minuses with our x's and our y's, so it does not shift left or right. So I know this guy has a center of 0, 0. Could I figure out what happens to the other parts of my circle, my unit circle? Sure, let's think about this. So my unit circle's at 1, 0. My circle's at 0, 1, 1, 0, 0, negative 1, so on and so forth, just like that. Okay, well, it has a vertical stretch as a scale of 5. So what do you think I'm going to multiply the y by? Times 5. So I should be at 0, 5. And what about the negative direction? Yeah, 0, negative 5. All right, that's not drawn to scale very well, but that should be right. Same thing with the horizontal. It looks like we got a scale of 2, so I just multiply the x by 2. So 1 times 2, I get 2, 0. And negative 2, 0. I'm going to do that in green so we can see it better. And negative 2, 0. And I can check that. Let's go ahead and graph just to be safe here. All right. Boom, get rid of those. But I need it y equals. So what am I going to do with this divide by 5? I got to get it to the other side, don't I? So I need to multiply by 5 to get that to the other side. So let's multiply by 5. So really I'm going to have y equals 5 times the square root of 1 minus x over 2 squared. So that's what I would do to graph this guy. So let's go over, let's go 5 square root 1 minus, and I better put this in parentheses, x over 2 squared. Enter, and let's graph. Now this is only giving me the top half of the circle, correct? And it looks weird. Sometimes your calculator gets a little goofy. This should actually go all the way down to 2. And if I looked, let me check. When my x is 2, I should have a y value of 0. I could look at my table here. So when x is 2, y is 0. So it doesn't work. Same thing. When x is negative 2, y is 0. So for some reason it doesn't show up on my calculator here. We'll have to walk around and see if it shows up on yours, but it should. And then if I wanted to do the other half of the circle, I would negate this. Instead of rewriting the whole thing, remember I can just negate variables, go into my y vars, and select y1 and graph. and I should get the bottom. So this should be an ellipse. It should connect all the way here. For some reason, it doesn't like to show it. It's kind of goofy. Okay. So same thing with this guy. If we take a look, now it just tries to trick you. This is really a vertical stretch of 2, right? Because it was really over here, y divided by 2, but then it got multiplied by 2 to bring to the other side. So whenever it's out front of the radical, that's going to be our vertical stretch. And then right here would be our horizontal stretch of 3. Okay, so you should be able to tell what that would happen according to our last problem there. So every single transformation we've done can also be done to a circle. So let's predict the shape without using a calculator. Let's talk about what would happen here. So for example, this guy, there's no vertical stretch, but what happens? It looks like it moves or it shifts left 2. Remember, not right, but left 2. It's always the opposite when it's on the inside. Remember, because it's x minus h. So this would shift left 2, and that's all it would do. And it would have a radius of 1 still. All right, let's do a couple more here. So I'm going to put this green one. So it looks like we have a y minus 3. That would mean it moves up 3, right? Because I could move it to the other side. It's really plus 3. So it moves up 3. And then in the x direction, does anything happen? Nope. So if I were to graph this guy, now my center, instead of being at 0, 0, would be at 0, 3, because it went up 3. And then it would still have a radius of 1, just like that. Very poorly drawn, sorry. So looking at my y plus 1 down here, well, remember it's always the opposite case if it's with the variable. So this is really down 1. And then over here we got right 5. So our center is moving down 1 from the origin and right 5. So there's my new center, and we have a radius of 1 still. So just like that. There we go. What about this guy? Well, this is just our bottom half, right? This is just the bottom half of the circle with the center still at 0, 0. So it would be at -1, 0, 0, -1. So it would look just like that. And then our green here, oh, we just negated the x. That's kind of goofy. Remember that? Reflects over what? This should reflect over the y. So normally, the top half of our unit circle looks just like this. If we reflect that over the y, like this is a mirror, don't you get the exact same thing? Yeah, that'd be the same thing, right? Because think, if I took x squared or negative x squared, like 5 squared or negative 5 squared, I get the exact same thing. Okay, so it's just the exact same graph, the top half of the circle. All right, now let's do a little extra to it. This is going to be kind of confusing now. All right, let's take a look at this top one. It has 2x. 2x. So it looks like it's going to have some sort of stretch or shrink, right? Usually we have it like with division, don't we? So what would that be, you think? Well, let's think about this. If I multiply by 2, that's the same thing as dividing by its reciprocal. So what is 2 as a fraction? 2 over 1. So it's the same thing as dividing by a half or 0.5. So really, this is the same thing as x over 1/2 or x over 0.5. So it has a vertical stretch of 0.5. So I'm going to draw my unit circle here. So let's draw my unit circle. So that's at all my 1s, right? So it's just like this. So now I have the same center, but what happens? All my x's get multiplied by 0.5. So for example, this guy was 1, 0, and this guy was -1, 0. So they get cut in half. So now I'm at 0.5, 0.5. Do my y's change at all? No, there was no stretch in the y, so those stay the same. So it's going to be a nice ellipse like that. So that's kind of tough to see. But I should still go up to 0, 1 and 0, -1. But now my x's got changed to 0.50 and -0.50. Right, because this got multiplied by each of the x's because of the horizontal stretch. All right, and if I had the same horizontal stretch, but then I had a vertical stretch of 3, right, because that's the same thing as y over 3, now I would just multiply my y's by 3. So instead of having 0, 1, we're going to go up to 0, 3. And same thing, instead of having 0, -1, we're going to go down to 0, -3. And then just like we did right here, this is the same thing, a horizontal stretch of 0.5, so right there and right there. So that would be my ellipse. Crazy. And I could check that with my calculator as well. I won't do it here, but you can. What if you're given the graph and you want to write an equation for the curve that got transformed? Well, first of all, always consider the stretch first, right? Consider the stretch first. So here's my unit circle. I might even draw it in just like this. Got a center of 0, 0. Well, let's go look. If my center gets shifted over to here, did it get stretched horizontally at all? No, it still has a radius of 1, so that's good. But it got stretched vertically, correct? It used to have a radius of 1. Now it has a stretch or a radius of 2. So really, I could just look at the radius, couldn't I? So I don't even have to look at what that new point is. Just look at your radius, your radii, I guess. It went from 1 to 2 for your radiuses or your radii. So what kind of vertical stretch would that would be? Yeah, 2 divided by 1 is 2. So it has a 2 scale on its vertical stretch. So if I want to write my equation, it'd be y over 2, right, for the stretch of 2 equals the square root of, okay, now we got to look and see how it shifted. It looks like it shifted 1, 2, 3, 3 to the right. Just pay attention to the center, right? I'm just looking for my center. Got 3 to the right, so I need to have that x minus 3 squared, correct? So it's 1 minus x minus 3 squared. And then it went up 1, right? So it went from up 1. So now my y, I have to put, there's a couple ways I can do this. I could put y minus 1, just like that.